things that are on our no, there are two things that are on our side. One is that we are human beings, and the problems that are the biggest problems that we are facing in this area are to do with the behavior of human beings. The unpredictability of the behavior of human beings. It follows that we need to bring into this people from disciplines who understand better about the behavior of human beings. Now, that was admitted in the framework that was put forward, quite clearly and positively admitted. And so conversations have got to go on along those lines in order to take us forward. In the meantime, we've all got to keep moving towards a better world. And the sort of stuff we're talking about here, particularly, I think some of the stuff that Gary has been putting forward about how do we deal with some of the big problems, the taxonomy, sorry, I've got lost the words at the moment. The what's it, Troncalis? Yes, his the word
isomorphies. Isomorphisms.
Yeah, well, I was thinking in terms of the bad ones and the good ones.
Pathologies.
Yes, pathologies. Yes, that's right. It's those sort of practical ideas that are going to help us on this path, I think.
Yeah.
That's why I think it's not an or, it's an and.
Well,
and
to a certain extent, yeah. I was listening to the conversation while I was fiddling with the technology, trying to get my earbuds to work right.
Interesting technical problem.
Yeah, but what I picked up on was a discussion that you started with on mathematics and generality and that sort of thing, so I wanted to say that I'm in another discussion with some mathematicians, Kent Palmer and Philip Boxer. Do you know any of those guys? I know Gary knows Kent, but Philip Boxer, have you ever heard of him? He's into requisite agility, and he's working with Amit Arora, who's got a group working on requisite agility, and one other fellow involved there, Patrick. No, not that's you're here. Sorry.
There are other Patricks around.
Getting my groups mixed up. But anyway, we had a 2-hour conversation a couple of weeks ago or a week ago, in which I wasn't able to say anything because I didn't understand a word of it. It was all about algebra, 3 different kinds of algebras, 3 different triality, octonians, and I'm going, what in the hell are these guys talking about? And I don't know why they wanted me involved. That somehow they feel like it's related to relational theory. And so I really thought about that. So, well, what's going on here? I mean, is it necessary to get into that? If I sent you one of the emails I just got from Kent, I don't think any of us could figure out what he's talking about. Now, do we need that in order to understand and work with the natural world? And I'm a natural scientist. I come from the natural world. And we try to simplify things. We say, well, what's the simplest model that'll do the job? It's parsimony, right? And scientists have a tendency, and I think engineers as well, to look at it as mathematics as a tool. And the difference between the physicist and the engineer, I think, is the physicist might be more interested in trying to perfect the tool, and the engineer is more interested in using it to solve a problem, if that's fair generality. But it's still the same attitude that the mathematics is a tool. But these guys are approaching it as they're going to discover something fundamental in the mathematics. And that's going to tell us how to deal with our natural system problems. And frankly, I don't think that's true. I don't think that'll ever be the case. I think it's an endless black hole, but a necessary one. You got to have the mathematicians discovering new patterns in logic that can be turned into tools. And then you got to figure out what the tool is going to be good for. And it could be that it's good for nothing. And it could be that the pattern is just an interesting pattern. You know, well, what have we done with fractals so far? You know, I've seen some great picture books, you know, and they're wonderful. And the concept is incredible. And I think it's appropriate and it describes a lot of natural phenomena, but is it a tool at this point? I'm not, you could probably tell me because I haven't worked that much in that field. But the problem that I found initially looking into fractals was that I didn't know how to go from observation of a natural system and the data collection to the fractal. You know, you could come up with a fractal that gives you very interesting landscapes, but can I go from the landscape to specifying the fractal? And it looks like a landscape, but I can't turn it into a model, is what I'm saying. Now, maybe other people have done that now, I don't know. But at the time, I couldn't see how to do that, how to go in the other direction, you know. So with the relational theory, I think it interests a number of people because it looks like it has something to it that is describing something. And then a lot of folks say, well, maybe I can describe that something better with a deeper understanding of mathematics. So we can go to octoniums, we can go to different kinds of algebra. Why is there 3 kinds of algebra? Well, I didn't know that was the case until I got into this discussion, but apparently there's 3 different types of algebra. And they want to say, well, how does that relate to relational theory? Does it predict 3 different types of algebra? Maybe, I don't know. It might be a subjective matching if it, you know, if it does. But the relational hold-on approach is a generalization. It's a metasystem generalization, and the question is it true as an extremely general picture of all systems? Is it possible? I mean, it's like discovering the Holy Grail, you know. When I found it, you know, first from Rosen's work, I thought, wow, that's incredible. It seems to work. It seems to describe every system that I've been able to test it against. And then when I found when my wife took me to India, you know, where I've been working and studying for the last, 12 years or more, 15 years, that really blew my socks off because all of a sudden I saw that it was a pattern that was written at least 3,000 years ago, and it's identical. And it applies to the human psyche, and it applies to human civilizations, and the nature of an origin of the universe. And I go, okay, so then I really felt like, okay, this is like finding the Holy Grail. But I think you still get the so what factor in the sciences and mathematics, because people say, yeah, okay, well, that's one way of doing it. You know, I've been approaching it this other way. Maybe I can learn something from what you did and get my octonians to work. You know? And we're dealing with this attitude, I think, that somehow the math is going to tell us the science, and I don't think it will. You know, so I guess what I'm saying is that it's incredibly difficult to explain the hold-on to people, and yet it's so dead simple. I think it could be taught, you know, in grade school. I think it would probably be understood a lot quicker and easier in grade school with a few metaphors. I mean, I'm thinking of making a game out of it so that it becomes obvious. But people want to go to a 3-part framework. They want to look at some extremely complex mathematics. Well, my attitude is that the mathematics is very, very important, because you need it in order to prove that your metaphysical framework, your intuitive understanding of it, is valid. So if it's not mathematically sound, you don't really have something that you can work with. And yeah, but I'm not going to derive the understanding and the metaphysical framework. I don't think I'm going to derive that. Well, although Rosen kind of did, but he was primarily a biologist. He just decided to be a mathematical biologist. Anyway, I'll shut up.
I think that in terms of the bridges that are referred to just now along the spectrum between, I could tell you a funny story about fuzzy sets, in as much as we got a meeting, when we first got into it, we got a meeting together of a philosopher, a mathematical logician, an ordinary mathematician, an engineering mathematician, and myself as an engineer. And it was clear that we were trying to talk to each other, but it was like this, we're just missing, we couldn't connect. And I realized that the conversation was futile in the end, because at one point, one of my engineering colleagues said, my engineering mathematical colleague said to the others, let me give you an example. And you know what? The reader in logic said, don't confuse me with an example.
Exactly.
Now, that whole, what he was interested in was the structure of the symbols and how they were dependent on each other to make deductions, etc.
Right.
And
you need those guys.
No interest in how it could be used.
Yeah.
So in order to communicate with him, you needed somebody in the same line, but a bit further along the spectrum. And then someone else, so A to B to C to D to E, and the engineer at one end, the practitioner, whether it's an engineer or a doctor or whatever, and a pure mathematician or logician is at the and concerned with the fundamentals of mathematics is at the other end. And the difficulty along the spectrum is sorting the wheat from the chaff, because in the 1960s, if you'd said to an engineer, what is a matrix? Only a few engineers would be able to answer that. They were working in the area of matrix analysis for structural analysis. And it was considered to be off the end of the practical spectrum of interest to practitioners. And so a lot of people rejected it. But of course, as long as one group of people were willing to carry on developing it, you ended up moving from finite difference analysis, which was useful but limited, into finite element analysis, which now is on every engineer's computer desktop to do a standard analysis of a system, whether it's a structural system like a bridge or in fluid dynamics like predicting the weather. and I'm sure Gary is completely familiar with the use of finite element analysis in engine design and so on. So it's a matter of picking up those important theoretical ideas that have potential for practical application and benefit, to pick those ideas up and bring them to fruition. And I am totally sure that the idea of the holon is like that of a matrix. Perhaps a little more remote, because a matrix wasn't particularly difficult to pick up if you had some basic math. But I think category theory is a bigger challenge. But nevertheless, I'm sure it's of crucial importance for the future. So I want to thank you, John, for the conversation we've had online, on
Likewise.
email, because I realized I should have done more reading before engaging with you on that, because I really didn't understand much about the whole thing. But you've shown a lot of patience with me, and I've learned a lot.
Well, I have too. See, it's very helpful for me to answer these questions, because I don't always ask those questions of myself, and I want to make sure that I actually understand my own theory. I don't even consider it mine. I consider it an extension of Rosen. So when I say, well, no, that's not true, and this has to be the case, I'm not talking about my opinion. I'm trying to read what the logic of the holon says.
Well, what I realized I didn't twig soon enough was that when you were talking about structure, you were talking about mathematical structures. So in my mind, I'm a structural engineer, so structures to me are physical things like a bridge or a building. And I couldn't get my head around how you were using the word structure.
Well, I hopefully will, at least in the future, always say mathematical structure when I mean it, because I use it both ways. And I'm kind of like you, that threw me for a loop at first, because I think of structure as a physical structure as well. And it's in the holon, right? The encoding of the model is structure in the holon. And that's a physical structure. That's not mathematical structure. In a way, it's mathematical, but that's just the way we model it, But the whole holon as a whole is considered a mathematical structure. I think probably schema is a better word that Kent Palmer uses.
Yeah, I think that clarification is very important. So we need to be clear what we're talking about.
Yeah.
I think that one of the areas where we are having a little difference is I'm so convinced by Popper's three worlds that I want to use it. And you're not so sure about that. And until I can place something in that, in one of those worlds, I'm not understanding what I'm talking about. And I think that we've got to the point where there's just one slight disagreement in the last exchange, where you'd got your source for Popper's views from Wikipedia, which I think is possibly wrong. I mean, I'm not going to say it is wrong, but I think it's wrong in that, as I see World 3, World 3 contains everything, all the languages that we share. So whatever we say to each other and understand, it is in World 3. So there's no limit to whether it's causal or not. But that's a World 3 concept.
So you associate World 3 with language?
Yeah.
That could work. Yeah, that could work.
Yeah, I see everything that we share, when we talk about a unicorn or Sherlock Holmes, a fictional character, or a force, or electromagnetic radiation, or any concepts that we share, we have our own world to views of how we understand that concept, but we share it. So, you know, when we learn what color is as a child, somebody points out to you, that's a green, that grass is green. And you say, oh yes, that grass is green. And then you learn to see other things that have a similar perceptual impression on you in terms of brain patterns as a green. Because if you're colorblind or you have a difference of view about that greenness, then you have arguments, and I have them all the time with my wife, because she thinks I don't understand color at all. You know, when I put two things together, she says, what's that color? And I say, it's whatever it is. She disagrees with me. So, but it doesn't really matter most of the time, of course. But there are, you know, there's no way that I know what you think of as green is the same as what I think of as green. Yeah. But we can talk about green quite comfortably. Right. We wouldn't disagree that grass is green unless there's been no rainfall because it's gone brown. So it's still contextual.
Well, maybe we should go. Sense? Yeah, it does. Maybe we should go through the three worlds in a little bit of detail and get that straight, since that seems to be an important connection that you want to make.
Could I interrupt?
I can send you a copy of the lecture that Karl Popper made, because I checked it, and it's online. But
okay, but you know, it was more important that we
really.
But I think it's more important that we agree on what they are, and not.
Well, to me, it's quite simple. World one is reality, which is unknown to us, other than through worlds 2 and 3.
What do you mean by reality?
Well, the world that we live in, but we don't know the nature of it.
Well, there's a lot of gurus in India who say that's not reality.
Yeah. Well, you know, as an engineer, I'm talking common sense. If I build a bridge, that bridge is in reality.
So let's qualify it. Let's say this is measurable reality or perceptual reality.
That's a percepted reality.
Yeah, I think we have to be, because look, if world 2 and 3 aren't real, then we can throw them away, right? Some people would say
we wouldn't exist.
Yeah, they wouldn't exist. So we have to be clear, you know.
Yeah. Can I just interrupt this conversation a little bit? And 2 or 3 things came to my mind whilst you were talking. One was that the idea of the holon is something which I think is as important or more important than your matrix methods, actually, and therefore we need to be persisting with it because of its value in understanding systems. And I want to give you hope, because you mentioned that matrix methods sort of came in at the beginning of the 60s. By the end of the 60s, I was using finite element analysis to actually analyze and design offshore structures. I had to use an Elliott automation machine to do it, a structural analysis package in that, but it was just amazing how quickly that came through, primarily because I was fortunate enough to go to Imperial College, where I was introduced to some of the concepts sufficiently to be able to link up with Winifred Muir-Wood, who was a mathematician, and Zinkovich, actually, and enabled it to be used, even though I had not got the mathematical understanding that's really necessary to deal with the solution algorithms. And so it's about understanding the concept and getting people to see why that's useful.
Yeah.
That I think then leads to the energy to do all the other things.
Yeah, then you start building the tools, because you have to think that way before you can build the tool to do it in a practical.
That's right, and you have to
environment.
have something which enables you to suspend your disbelief.
Yeah.
Because until you've got some practical example that you understand that enables you to suspend your disbelief, then you're always going to have problems.
But
so
I do want to go back to the three worlds, though, because I don't want to leave David in the lurch here. I think we can probably do a pretty quick matchup with the three worlds, but we have to be willing to make a slight modification in how they're interpreted. And that's what the hold-on would do. It would say, okay, if it's going to fit with the three worldview, we have to ensure that the three worldview satisfies the same logical criteria that the hold-on does. And that's all I was saying in our dialogue there, was that there might be if we go to the idea of language in world three, we're getting very, very close. And I think there's just one more step to make it work. But can we just go through like world 1, 2, and then 3? So world 1, I think we're agreed. That's the material physical world. That's things we can observe. That's state, physical state. Is that how you see it, David?
Yeah.
Yeah. And then what then world 2, I think we have to, what's the idea? How do you see world 2?
Well, it's a physical state of the brain with its emergent property of consciousness.
Physical state of the brain. Oh, hold on a second.
Sorry?
I have a worker outside and I think I'm being called. Can you give me like 2 minutes here?
Yeah.
Yeah, certainly. Yeah.
Sam wants to know what happened to all those shims.
I've never had a questioning of world 1, 2, 3. Whenever I try to talk about it with anyone, they don't want to know. So it's interesting to talk to John.
Well, David, that's not true. I've always wanted to know.
Pardon me for about 3 minutes.
So you and a few others, Patrick. Yes. But,
yeah, I have to go.
You're not questioning it quite like John is doing.
No, I haven't.
Can I beg out for about 3 minutes? I have to go down and get some wood shims for our worker.
Okay.
Okay, I'll be right back.
He's gone again. So, to test it against someone who thinks deeply about these things is very helpful.
No, I understand that completely.
I've never really been challenged. And my understanding, of course, is second-hand. And it's Karl Popper, who I've read carefully. But of course, I find my views about him quite at variance with a lot of other philosophers. Although they seem to think he is the greatest scientific philosopher of the 20th century, they don't all agree with the conclusions he came to. So, how does it strike you, Gary? Gary, can you hear me?
Yeah, I can. No, I was just looking at some of the diagrams on Popper's worlds on the internet. Can I share them?
Does world 1, 2, 3 make sense to you?
It does the way that the diagrams show it. So
Which diagram?
well, there's this one.
No, no. We've got a diagram in our book.
Okay. I might be able to find it. Hang on. What was the book title again?
Of doing it differently.
It's in both versions.
The latest one, because she changed it in the second edition. Don't know whether I can find it.
Is it described as the three worlds of knowledge?
Yep. Popper's Three Worlds. I'll tell you what pages it's on.
If you have it, you can share it.
I have it electronically somewhere, but it take me a little longer to find it.
Okay, back.
Yeah, it'd be helpful if you could share the diagram.
I will do in a moment.
So what have you decided?
We're looking for a diagram.
I got it. It's
Yeah, can you share?
figure 5.2, page 91. I can put it up here. I don't know whether you can. Oh, you won't be able to see that.
No.
Hang on, I'll get it electronic.
Yeah, if you've got the diagram, you can share it. I've enabled sharing.
Yeah, I got to get it first now. Hold on.
So
Why don't we
May-
talk? Well, it may be useful to have the diagram for this discussion that's needed.
okay,
I've just got to get into the right bit.
well, would it be fair at all to say that world one is body and world two is mind in the traditional mind-body duality?
Yes, except that it's not a division. World 2 is contained in the brain and therefore is physically in world 1, embedded in.
Huh. Yeah, that wouldn't work with the whole-on structure. Because they're both physical in that case. So where does the mind come in? Is that world 3?
Well, that's when you struggle with consciousness.
So that's okay. I would be happy associating world 3 with consciousness and language in the sense, not of language itself, but of the translation between languages. Does that make sense? In other words,
Yes.
going from French to English is world 3 in the whole-on view.
It certainly would be, yes.
But the language itself would be world 2 in the way I look at it, because that is the formalism that describes the physical world. That's our mental way of modeling. So world 2 would be models, speaking very generally. World 1 would be the measurable, perceptible stuff that we model. And then world 3 would be the connection between them.
Yeah, I'm not sure about that.
Well, see, the only
I-
reason that I have some confidence in that is because of category theory. I can show mathematically that that works. Whereas the other structure, the other interpretation of world 1, 2, 3, I don't know of any proof that it's logical. We might like it. It might make intuitive sense. But see, this is where the math does come in. We're not deriving it from the math, but we're testing it. And can you show that it's consistent, categorically consistent? And I don't think so, because you've got a conflation between 1 and 2 with physical systems. These aren't distinct worlds. And,
Share screen.
I need to think about that.
Hmm.
Can
not
I share
sure.
Please.
screen? now?
Yes.
Okay.
Have we got the diagram?
It should
Oh,
have
there
come
it
through
is.
to you there.
Yeah.
Can you see?
Yeah.
Is it big enough to read? I might try to make it bigger. Hold
Yeah.
on.
Make it bigger.
I'm doing my best.
Well, you can also go to the full screen view on PowerPoint.
It's not PowerPoint, it's
Oh.
from a book. I'm sorry. It's from a
Oh, okay,
PDF.
so- okay, fine.
All I can do is close down the other things as we go.
Yeah, you can go into your view and turn off the people too.
Doing my best. Sorry.
No, I can see it.
Yeah, I can see it.
I can bring it up a bit more. Should be able to. Is that okay?
Yeah.
That's
Now,
the
how does
diagram.
that diagram square with what you just said, John?
Okay, the world out there, world one, the physical world, that squares fine with world one. Personal and subjective world two. Now, tell me what shared intersubjective world three is.
Well, personal and subjective mean things like I have a pain in my tummy. I have a pain in my stomach. You can't know what that statement means because my perception of pain may be quite different from yours. So that's entirely personal. Now,
Subjective, I understand. What is intersubjective?
You got me there for a minute. I did have that clear once, and I've forgotten the exact definition to be precise. But I got that from Stephen Kerner, who's a philosopher. And I know that there is, I can't pull it up because there is a definition in the book, somewhere in the region of that diagram, Patrick.
In the context of what you just explained in terms of a pain, yeah, this is where you'd be having a conversation with somebody else about pain. You both experience potentially pain differently, but you have a shared reference in the library.
Okay, that's the objective of others, world three, the library.
Yeah, yeah.
So that would be the shared reference.
Yes, yeah.
And then what would be the intersubjective?
Here we are. There's the bit that you were looking for, I think, David. Where my cursor is at the moment. These perceptions are intersubjective, i.e. shared. However, each of us perceives things slightly and sometimes dramatically differently. And the processing we then perform on our perceptions inside our brains is personal and therefore likely to be different. Is that not what you meant?
Yeah, what it means is that when we're looking at a table in world one, we are seeing the same table, but we are perceiving it slightly differently.
Correct.
That's intersubjective.
Yeah.
Now, which world is that? Where the difference?
Intersubjective.
That's why is it inter? I don't see that. It's my perception. It's different than yours, but what makes it intersubjective? It's simply subjective.
Well, because the world one object is clear, unlike the pain in my tummy. I agree that's a debatable point.
To me, the importance of this comes really home to roost when we realize that in order to deal with complex problems, we have to learn together. And so the degree with which we can actually agree about or understand each other's perceptions of things becomes actually essential to our transdisciplinarity.
Well, that's that's the case, and that's why I used the word dependability, which we discussed before, John, to mean the fact that we can exercise a duty of care to society by using information that we think is dependable in the context for which we're using it to make a decision. So I discussed this in my first book in 1980 in some detail. I think I sent a reference to it in one of the emails. But it's tied up with the sufficient condition for dependability is repeatability. So if we can repeat an experiment over and over again and get the same results, more or less, then, and there's some other criteria around that to do with clarity and levels of agreement within the repeatability, then we can use that. So if we know that, you know, there's an object on the table, and if we push it off the edge, it will fall to the floor. And every time we do that, we can say the object will fall, and we can predict that the next object will fall. We can say that with some dependability. There's no real concern there. But of course, if we were actually underwater with some object on a table bolted down and we pushed it, it'd probably float upwards. Or if we were in space, in a spacecraft, then it would float in midair, so, or mid-space, I should say. So it's context dependent, but that concept of dependability to me replaces the idea of truth. So we can not worry about truth. I mean, obviously truth is important. I'm not saying it isn't, but as decision makers, if we try to pin down what's true and what's false, we have great difficulty. So what we do is use dependable information, and if people agree it's world 3 dependable, then in a court of law, we will be exonerated if something goes wrong, having used that information, because none of us is perfect and no evidence is certain. Does that make sense?
Yeah, it certainly makes sense. I'm not sure it makes analysis, and that's where I'm trying to go.
Can I be controversial here, John?
Sure.
I think we're bordering on some of the areas between complex and complicated. If we realize that if we're in the complex zone, and I mean that in its full sense, including human perceptions and so on, then cause and effect are not necessarily easily analyzed. Indeed, the dependability of getting people's perceptions to align is dependent upon their attitude of mind, apart from anything else. And so you're bound not to get all people's perceptions to align. What we do discover is that there is a very long history of ideas and concepts which have matured through human interaction. And this is where I think that this connection to nature is so important, because human beings, although they've not been around on this planet for much of the life of the time life's been around, human beings have actually managed to create a degree fairly well on an awful lot of concepts, actually, and they're still doing it. There must be something about the way in which human beings communicate and share things, which is quite powerful. And I don't say it's restricted to human beings. I personally believe that I think we're beginning to understand that creatures like dolphins and whales and so on and so forth have their own particular way of looking at things, which may be as powerful, if not more powerful than our own. I also think some of the communications through that we're beginning to hear about in for example, the communications between mycelium in forests and so on are amazing in the way in which they lead to better outcomes for them. I'm looking at an ancient woodland just outside my house here. In fact, the background to my picture is of that woodland. And we have ash dieback coming up the valleys, but I'm praying and praying that ash dieback doesn't actually move into that woodland where there are a lot of ashes. But so far, it hasn't. And it could be because that woodland's been there for probably several thousand years, and certainly for more than 600, because that's what an SSI is in this country, Site of Special Scientific Interest. Now, if I'm right, we're going to see that the resistance to what is a fungal invasion, which is what ash dieback is, which stops it from being able to suck water up the tree, that resistance may have its answer actually in the evolution of funguses within forests. And I think that could be really, really interesting. It's showing how the collaboration between those fungi has enabled it to attenuate the invasion in the same way as flu used to kill thousands of people. And actually, the number it kills, even without the flu vaccine, is actually relatively small now, as it's attenuated its lethality to actually improve its prospect of being able to hang around. Because if it kills all its hosts off, it's got nowhere else to go, basically. And that's what happened with the Black Death. 2/3 of the population were wiped out by the Black Death, but the other third learned to do something about it and slowly to attenuate it. So it seems to me that this diagram has got an awful lot behind it, an awful lot of an understanding to make the sense of it. If this can be tied up to the view of holons, so much the better, but it needs a clarity of understanding to do it.
Can I share something that might promote some discussion, useful or not?
I do want to say first, Gary, that
Go ahead.
because I have a worker here, I sort of promised that I wouldn't go too long on this conversation. So maybe we could give it like maybe another 20 minutes or half hour, something like that. How does that fit with other people's schedule?
That's all right for me.
I have to stop at 5 myself anyway.
Whatever.
Okay.
Right. So, yeah. So we did some work trying to make the relational model simple to understand for the purpose of the paper. So this is really a simplified expression of relational activities, if you like, the relational processes. And this we did this together, John. So we have things which are a source and sink of signals and data. Yeah. In the
Can you
center.
make it a bit bigger, Gary?
Yeah. Maybe not that big.
Right.
A little smaller, perhaps. I'll go into full mode. Maybe that'll help.
Yeah,
Is that better? Yeah.
Yeah.
Yeah. So
Well, that's good. Yeah.
things are a source and sink of signals and data. Yeah.
Yeah.
But unless you go down to absolute zero, when there is no relations, yeah, everything is a source of sink of signals. Everything radiates, yeah, and everything is in relation, yeah. So these signals and data provide informational events, yeah, and then this is where observations take place. This is where information arises. Now, the next step is information is organized. Yeah. So knowledge is organized information. Yeah. And that knowledge, that organized information then provides essentially the forces, the enabling constraints. So that the forces that we observe, the electromagnetic force, the nuclear forces, the strong and weak, these all result as a result of this organized information. And then those forces then act on mass and energy of material things. And new things can result as a result of the forces. And then at the next spin of the holon, at the higher level, there are new sources of signals and data. So we go from nucleons to nuclei, to atoms, to molecules. Every spin of this is essentially a new level of let's say, physical abstraction, physical things. Now, when we talk about Popper's three worlds, this is one way of that came to me in terms of interpreting it. So this lower segment here is the physical world. The forces, the mass and energy of things that we see in the physical universe. Yeah. Now, when we talk about world 2 and world 3, isn't world 2 and world 3 all in this area about knowledge, and our subjective knowledge, our individual subjective knowledge, and the reference collective knowledge? Isn't that where that fits?
yeah.
Well,
Certainly you can interpret it that way, but let me just say, first of all, that what Gary has shown here is a holon, obviously. And while I would probably put different words in the boxes, in the colored ovals there, depending on the semantics of a particular discipline, that is characteristic of using holons, is that the words that you use for each quadrant will be different depending on the problem you're looking at, the discipline you're looking at it from, on and on and on. So words like event might mean something different to a physicist than to the way Gary is using it here. Things, things might mean a physical thing, and it would be in world 1. But here, things in my terminology would be entities, which are whole entities. So the middle part of the holon is the whole. It's all of the diagram. It's because when you have the arrows are what's important. When you have those arrows commuting the way is implied here, then you get an identity, mathematical identity, because you can replace the circle with one arrow, which is technically a mathematical identity. So you get identity out of the closure. So this is a holon. And then the only question is, where are we going to put world 1, 2, and 3 so that you get a matchup between the holon logic and the Popper's logic? And the question, I think, would be, is it a useful structure if you put world 2 and world 3 into the same quadrant? And I wouldn't think that you would get an analytical system if you did that. That's why I said earlier that it makes sense world 1, 2, and 3 as defined by David is certainly a sensible way to look at the world. I mean, if it wasn't, he wouldn't have, and the people you're referencing wouldn't have thought of it. So I don't have the idea that this is right or this is wrong. Everything is correct, but we don't know whether it's a useful analysis or not.
Mm.
And
But
so, yeah, so I would shift the world 1, 2, and 3 around a little bit in the diagram, not change anything else, because those are the terms that relate to the way Gary's thinking about it. And
what's missing? It somewhere in the hierarchy, going up from the is the brain and the consciousness that emerges from the connectivity of the neurons in the brain.
okay, so I
So
would say
this-
that's not missing here. I'd say that's explicitly shown.
Well,
brain-
it's higher up. In other
Yeah.
words, it's the old philosophical problem. If there is an avalanche in the Antarctic and nobody's there, was it Barclay or that posed its problem? Does it make a noise? Well,
Well, see,
yeah,
I can look at
this
this
model.
diagram. I'm sorry, I can look at this diagram
Sorry?
and see it as a picture of the brain.
Mm.
So and the
another-
brain physical aspect, which is in the lower part, and it has a mental aspect, which is in the higher part. And then I have a brain.
Yeah.
Then what happens in the middle is consciousness. Consciousness is the translation between the physical and the mental. Can you imagine anything that you consider conscious or conscious experience that doesn't involve both some kind of object and some kind of subject in relation? The consciousness, I think, is the relation between them.
Yeah, I go along with that. But I just wonder whether we should continue this or whether we should really talk about how we use the way of thinking in your 4 causes to inform
We can do, I
engineering
think we can do
decision
both,
making.
David, because I think a very simple clarification of world 1, 2, and 3 would work, and Gary pretty much just did it. Could we see that diagram you just did, Gary?
This one.
No, the one with the lineup on the, yeah, that one.
Yeah, because I was thinking that,
this is-
maybe what we're talking about here is these are different systems. Yeah.
Yeah,
And there's essentially a spin of a holon going up.
Right.
Yeah. This is
Right.
the physical world, which is experiencing itself. Yeah.
Mhm.
This is the subjective world where someone is experiencing the world. Yeah. And then and then when people get together, they build a common reference, which is another world.
Okay, but let's
Okay.
get
That's
to,
exactly as our diagram.
yeah. but
Yes,
let's-
it is. The Venn diagram on, if I went back to the diagram we showed it as a Venn diagram, it's saying same thing.
Yeah.
Okay, but I would interpret it a little differently. I would say world 1 is where Gary has it.
Mhm.
2 is on the top, is the contextual system, which is subjective. And world 3 is the horizontal line in the diagram. It's the functors that connect world 1 and world 2. That would be the holon logic.
Okay.
Could you draw that for us?
Yeah, Gary, just
I can
put
try.
world, just put world 2 up next to contextual system, world 1 at actual system, and world 3 next to the horizontal line. Yeah.
Like that.
Exactly. So if you do that, now your library is in world 2. And it's the non-physical images of the physical. There's no consciousness in world 1 or world 2.
Surely library's got to be in world 3. Library
I
is shared.
suppose it depends on what you mean by library. I'm thinking of it as like memory.
Oh no. Yeah.
Oh,
What
Well,
is it?
Popper meant everything that we think that we share.
no, there are a library of books. The concept
We-
of the library is a sharing
We
mechanism.
are operating in world 3 as we speak.
Yeah.
Yes, well, we're operating in all 3 worlds as we speak. If the whole on
Yeah.
is correct.
Of course, I mean, we live in the world 1, obviously.
So
That's
that's the thing to
taken-
realize is that the structure is not the structure of reality. The structure we're showing here. Oh, don't go away from the diagram.
Sorry.
Okay, yeah, great. The structure is not the structure of reality. The structure is the way we're going to try to take it apart, which is the definition of analysis. I mean, we took it apart in classical science in a different way that was very limited. And now we're going to take it apart in a new way that will give us more tools. But we're not describing what's really out there in nature. Nature isn't really divided between world 1, 2, and 3. This is the way we experience it. But the thing
Yeah,
about
this
science,
is a world 3 model of the universe.
yeah, so the way the Holon would look at this is world 2 contains the models, one's subjective knowledge. So that would be all the percepts that I have non-physically in my mental awareness or in some mental awareness. Take humans, let's get to humans later. We're trying to get down to the most fundamental structure of the universe before there were humans. Okay, or before there was
Yeah.
life. And we're saying there's a physical, if we were able to look at it before there was life, we would still have this cut in the horizontal line where below it we see a measurable world because we asked the question, and an interpretation, an experience of that measurement, again, because there was an entity asking the question. So the entity's right there in the middle asking this question, and people throughout the ages have found that we can't ask a question without seeing this split. So the real issue is, how do you see the split and yet see it as not divided, see it as whole? And that's what the Holon is doing. So then world 3 becomes the translation. It becomes the non-computable function that can connect a computable world that you observe in world 1 with a formal world, which is inverse to world 1. It's the opposite. You see how the arrow undoes what was done in world 1. You're going from function on the left to structure on the right. And in the top part, which I would call world 2, you're going from structure back to function. So that's what makes it whole. That means you have a completely commuting relation of 4 causes. So world 3 becomes the way that the top is connected to the bottom. If you notice the vertical line, we could also say, well, how is the right connected to the left? Well, that's not as big of a problem, because in either hemisphere, top or bottom, the connection between the 2 causes is a logical connection that we can formalize. So on the bottom half, we've done that in classical science. We just have state and dynamics. The dynamics are the lower left quadrant. The states are the right quadrant. The lower left specifies how the lower right changes. But as Schrodinger pointed out in his book, What is Life? None of classical physics or even quantum physics at the time had a way of going in the other direction. And that's all that we've added. We've added the way of going in the other direction, which fundamentally changes physics. And it hasn't happened yet because people aren't agreed that they're willing to do that. But they do it without saying it. It's embedded in the models that are being produced now. So what the problem is, okay, so we have in the either upper or bottom hemisphere, you have what's called an entailment. The arrows, the head goes to the tail of the other arrow, and that's a causal entailment. You have a force results in a change of state. That can be modeled as a unique, you can decompose that into unique entailments. And the same in the top, in the mental world, or whatever we want to call that, the representational world, the symbolic world, which is non-physical, and I say non-local, which annoys people. You have the same idea that the final cause entails the formal cause, and you can write, you can formalize that. But what you can't formalize is the crossing of the horizontal line. You can't say how a formal system, call it a model, and just think of it very simply as in science, the models are on the top and what we model is on the bottom. And so scientists are doing this all the time, and I'm just saying that nature does it too. But you can't formalize how a model gets turned into a physical system. There's a non-computable function there. So category theory came up with this idea of functors. And it's not an entailment, it's a functor. So the vertical connections up and down are functors. The horizontal connections left and right are entailments. And the functor is the weird thing, right? It's the thing that we can't formalize, we can't pin down. You can't have a one-to-one relationship between the top and the bottom. There's a big argument we've had for 2 years on the consciousness discussion list with Ram Vimal. He has a theory that's very much like the holon. We thought we could integrate them, but he's dug his heels in and he says, no, it has to be a one-to-one relation. And Kathy Reason, who's a mathematician, logician, comes in and says, she's proven that that won't work. And I was saying, well, Rosen also proved that that won't work. It can't be a one-to-one relation. So that's where you get the fuzziness, is going from top to bottom or bottom to top. But we can deal with it. Now, the thing is, with relating this to the, I would say, more sophisticated concept of the three worlds that David was presenting, we'll get the three worlds and that Venn diagram overlap. But by showing the Venn diagram overlap all at the same level, it's conflating things. And that's where you start to lose the power of the analytical approach. So we can get there because nothing is just a single holon. There's multiple holons, and this is contextualized within other similar holons. And we can certainly show the Venn overlap of these worlds in more sophisticated structures. We're trying to boil this down to an analytical system that can exist at the lowest level and be, like in the ideal of the classical science was to have building blocks of nature, Well, I thought they were physical things, but that didn't work. This replaces the physical building block with a complex building block. And so we can definitely describe the exact diagram you showed earlier for world 1, 2, and 3 using these building blocks. Think of them as Legos. we can build it, but it's not going to be a simple single diagram like that. Just like this is not a single a diagram of any complex system. This is a summary of all complex systems at every level. And to get more detail, we have to build it out. Does that make any sense?
John,
Or am I just
I have
rambling?
to say that you've lost me a bit there, so I'm going to have to replay the recording.
Sorry.
Listen to you carefully,
Hmm.
but in order to expedite that, could Gary put the word structure and function and the different of the four causes on the diagram, so we can be clear that we are what it is that we're saying. So that quadrant is what?
That's final cause.
Final cause.
Yeah, that would be final cause. And copy your box down to the horizontal line, and that's structure. But let me do a little trick here and say, let's not, just for clarity, since we're talking about it, don't write structure, write structor. structor.
Structural, yeah.
Okay.
I'm
And
happy
then
with
on
that.
the left, do functor.
Functor on the other side.
Yeah, so these are structure and function the way we normally talk about them. But these are both functors, and I don't know if anybody will ever pick up on it, but since they're bidirectional, I suggested calling one structor to match up with functor. Yeah.
Let me see if I can remember. I think this one's formal, isn't it?
Yes.
Efficient, is it?
No, formal.
Formal.
Yeah, because efficient is where we apply design.
No, formal is design. Efficient is where you.
Ah, no, I'm talking. There's a difference between architecture and design.
No.
This-
That bottom one has got to be efficient.
Yes, that's what I meant. Yeah.
But design is formal cause.
No, it depends.
Oh, yeah?
Yeah, there's a difference between architecture and design. Yeah, architecture is essentially organizing, and design is working out how.
Well, I don't agree with that, Gary.
Well, I'm sure you won't.
I think they're both aspects of design.
Yeah.
One is to do with
Yeah.
elegance and aesthetic, and the other is to do with function.
Yeah. Again, we're using words in different ways. Yeah.
Yeah, but here.
I really
efficient-
dislike the fact that in Code uses the word architecture, because in my end of engineering, the division between structural engineers and architects is very debilitating.
Oh, I agree. No, you shouldn't split.
It is the
functions.
worst thing that could have happened.
Yeah.
But historically, you can see why it happened, and you can understand why it happened. It stems from the ability in ancient times to be able to aesthetically draw a building. And that was what was important to the client, because there wasn't really any structure other than some rules of thumb about proportion and so on. Whereas the emergence of engineering science of structural analysis has now created the structural engineer, and all the time they are at loggerheads. It really is very unhealthy.
Yeah.
And one of the biggest problems, and I don't want that to happen
Yeah.
to systems engineering.
Yeah. No, I agree. I agree with the problem. Yeah.
The problem's enormous because we're now dealing with the concepts being used in it's not just engineering, it's all whole, as we were hearing earlier today, it's holding a much wider set of disciplines and so on and so forth. And we have to, you can't change how people use words. We haven't got the power to do it. All we can do is to make sure that we get the right understanding of what we mean by the words we use. I'm afraid I'm a pragmatist as far as that's concerned. But I'd like to see this diagram just completed in one other way, Gary. If you would move the two words conceptual systems up a little bit and actual systems down a little bit, you could fit in world 2 and world 1 in between those, in there. And we now have what I would say is a very elegant diagram.
I would agree. That's exactly the way I would see it. Because world 2 is both upper quadrants. It's not one of them, it's both.
Yeah.
Mm. Yeah.
That's why I was going to put it underneath the word contextual systems.
Absolutely, yeah. But you see now, is this true, what we've done? And what criteria are we going to use to decide whether we consider it true? In the diagram that David showed, that's true in this with, and I think of congruent. What is it congruent with? It's congruent with certain experience that people have had. This is the way things appear to work. So it's true. What I'm trying to do with the whole on is I'm saying what is true at a very fundamental, logical, analytical level. What is true analytically? Now, the test of that is going to be, well, first of all, does it hold together logically? And that's been tested, and it seems to, although there is some question about whether the whole thing can be formalized. And in fact, it probably can't, because functors can't be formalized. But that doesn't matter. It could be a limit of mathematics. We just simply can't specify what the functors are. That's not a problem, because the overall analytical method will take care of that. And I'll explain that in a sec. So this is, if it's true mathematically and at a fundamental analytical level, then we should be able to describe what you found intuitively true or experientially true or operationally or professionally, or however you want to say it. We should be able to describe that with this causal structure. If we can't, it isn't your diagram that's wrong. If we can't describe your diagram with this structure, it's this structure that's wrong, because we're proposing a structure of everything.
Well, I think that the difference between mathematical truth and physical truth, if you like, is that mathematical truth is based on a set of axioms which we consider to be true, and we deduce from those axioms propositions which are therefore true because they are deduced from the axioms. So it's a top-down analysis of truth. In the physical world, we're a bottom-up analysis. So your correspondence, or what's the word you just used?
Congruence.
Congruence is what Popper would have called the correspondence theory of truth. And that means that when we make a statement, it corresponds with our perception of the reality of world one. So it's a bottom-up definition of truth. And I think what we're doing here, in a sense, is to bring those two together. And if we can do that, it will make a significant contribution to, as it were, making the whole idea respectable.
One change I would
that's
suggest here.
right word to use.
Sure. One change I would suggest here is instead of in World 3 collective reference knowledge, I'm not sure if we have a referent there. The referents are top and bottom. I would say collective
Yeah, that's right. That's correct.
translational knowledge would be good. Knowledge is fine. That's knowledge, but translational
Well,
knowledge.
I'm going to have to go away and think about this a lot.
Yeah, and I have to go work because I have a work.
So,
Work with them.
I think that's helpful, and we've got the diagram on the video. So,
Oh,
Once you make
that?
that translation, AL at the end of translation, does that work? Yeah, translational knowledge.
Can you, Gary? Can you send out the diagram separately
sure.
by email or something?
Yeah,
Just
well, I'll download it into a PowerPoint slide and send it around.
yeah.
Between now and our next talk, I will try to describe what David presented in that diagram of well 1, 2, 3. If you send me the paper, I can look at that at his definitions too. And I'll try to describe that with holons, and then we'll see the matchup.
yeah, I'll send you the link to the paper. It's on the web.
Right.
But I think what it's helping us to do is to see the role of people in the whole thing, because what I think my conclusion from our exchange was that science, in a way, tries to exclude people. It wants to talk about concepts and things without reference to people. Right. Whereas as engineers, everything is done by and through people. So, you know, one of the first attributes that I give to the process, which I, you know, as I describe it, is who is the process owner. In other words, through that process, there will be a decision.
Right.
And that decision is owned in legally the duty of care to society by the process owner.
Yeah.
And if he gets it wrong or she gets it wrong, then they are liable in some sense. And if it's negligent, they are punishable. But of course, a lot of the things that are accidental or unintended may be blamed by others and lawyers to be negligent, but in fact are not. And that's a big problem, I think, when accidents happen that aren't anybody's fault.
Yeah, I'm really concerned about that with these self-driving cars.
Oh, that would be a big problem there.
Yeah, it is.
That would be a big problem.
Can I, I'm sorry, I have another Zoom to do.
Yeah,
I've been at it now so I must say goodbye and thank you very much. I think we're making enormous progress. And if I could see out of this a paper which makes the connection between relational theory and Popper's worlds and the way we take decisions and all the rest of it we got on this diagram, that would give me real inspiration, because it's an example of how we can use things to connect things up. Yeah, and that's really important. And if it connected holons up, I'd be even more delighted.
Before we leave, John, I want to try and create a single paragraph description of the 4 causes, which will marry, we can both agree on, which will marry the relational view with the commonsensical view. I've drafted some ideas and I'll send them to you, or maybe you would prefer to do it yourself.
I've already done it in papers, and I would try to be consistent with that. But yeah, let's do that.
Yeah, that would be very helpful, because then I think that will enable us to in this stream of bridges translating from one area of specialism to another,
Yeah.
it will enable us to translate into language that our colleagues who will not look at category theory or relational theory
Well,
at
the big
all,
problem is
but
that,
we've got to explain it to them in a
Of course,
language
yeah.
they can understand.
but the big problem with that is that I've had to redefine two of those causes. And for, what is it, 2100 years since Aristotle or longer, 2300, it's been confused. And we've had a definition of formal cause that's ambiguous, and so it makes it very unclear, where it belongs and what it does. And there were two examples given typically of formal cause that place it in different positions. So I tried to clear that up, and then final cause was conflated or interpreted in a human way as purpose. But at the time, purpose had to be some divine intervention type of concept. It was outside the system. So I had to redefine final cause as anticipatory or exemplary causation, the effect of a previous condition on future models of what will happen in nature, future possibilities. So previous reality on future possibilities. In the East, that's called karma. And so I redefined it that way because that puts it inside the system. But as long as people insisted that final cause was outside the system, they could throw it away and just have classical physics. So that's the reason for the definitions.
Yeah. Okay.
Right.
Okay,
Well,
thanks, everybody.
we'll leave it at there for today, shall we?
Yes.
Yeah, let's agree on the next meeting by email. I mean,
Yeah,
yeah,
thank you very
send an
much,
email,
John,
suggest a time.
particularly.
Thanks.
Right. Bye.
Cheers, then.